Taha, can you see this slide, please?
Yes, sir.
Okay. So this today we are we will be talking about some problem solving session in which we will be carrying out some CNC part programming. We had discussed the CNC machines and its part programming in the previous two lectures. So today, just for practice, we will solve two problems for CNC part programming, and moreover, more so, I will be giving you an overview of the CNC simulator, which I had already shared with you on LMS. So you people might have opened it up and installed it on your PCs. But if not, so we will have a small session today about the CNC simulator, the use of CNC simulator also.
Sir, can you repeat this?
Please.
सर मैं क्या था कि आप रिपीट कर देते हैं जो अभी आपने कहा है.
I have just given you the introduction that what we would be doing today. So we will be actually solving some problems for CNC part programming, and we will be discussing today the use of CNC simulator as well for CNC part programming. So that is something which I have discussed until now. So let us start our today's lecture, and we will be talking about um, writing down the CNC code. So let us see if we look at this example. So the requirement of this example is to drill 3 holes. So actually 3 holes are to be drilled in the part as shown. So these are the holes which are to be drilled. This is one. Let me just mark it like this. Then what would be the second one would be, let's see, we call this as the second, and we call this as the third. So these are the 3 holes which are to be drilled in this piece, and the piece looks like this. So in fact, we do not have to carry out any other activity on this piece, and this piece is 10 millimeter thick. So this is the thickness is given. So the part is gripped and placed in mill machine such that its top surface is 40 millimeter above the surface of the machine tool. Okay. So surface, so X, Y, and Z are defined as the Cartesian coordinate system. So we would be dealing with X, Y, and Z axis. And this is something which we need to keep in our mind, that this surface, the top surface of the workpiece is 40 millimeters above the machine tool surface. Okay, a 7 millimeter drill corresponding to the whole dia will be used. So this is a drill machine or a drill bit which is to be used, which has a dia of 7 millimeter. All right. The drill will be operated at a feed of 0.05 millimeter per revolution and a spindle speed of 100 RPM. Okay, this is good. So at the beginning of the job, the drill point will be positioned at a target point which is located at x0, y minus 50 and z10. So these are the dimensions, or these are the location of a point which is given to us where our drill point will be before the start of the program. The program begins with the tool's position at this target point. So our target location, our tool location would be x0, y minus 50 and z10, from where we will start writing our program. Okay, so this is the job which we want to make using the G and M code. So here we go. So this is the job. Let me just again write down that we only have to drill hole number 1. Probably we call this as hole number 2, and this is hole number 3. So these are the 3 holes which are to be drilled. All right, let me just put it here again. This is hole number 1. Again, this is hole number 1, hole number 2, and hole number 3. All right, so let us now look at the program code which we have. So number one thing is that you must understand and you must keep this thing in mind that this is how if you have asked to write down a program, a CNC program in the exam, so this is how you have to write down the program. So this is the format you have to follow. So NC part programming code and comments. Actually, the comments would tell us that what do we want to do in this line of code. So let us see. N001, we know what this is, the line number. G21 is actually the dimensions in millimeters. So let me just keep writing these so that okay, so G21 depicts that we are dealing in millimeters. Let me just put it here so that we are dealing in millimeter dimension. G90 is depicts that we are working in absolute coordinates, and G92 is actually giving us is defining the origin of our axis, which is given to us as x0, y minus 50 and z10. So this is another thing which is to be kept in mind, that you need to write down the code in 3 figures with a point at 0. So let's see if I need to write down minus 50.5. So I'm going to write it down like this, minus 050.50. So this is how I have to write it down. So this is the code, the format of the code, a format in which the code is to be written. So now we have defined all this, we have defined our origin. So let us see now what is to be done. So now let us see at N002. So what are we doing here is that we are rapidly moving to the first hole location. So what is the first hole location? If I look at here in the in this diagram, so in fact we are moving 70 in x-axis, we are moving 70 in x-axis and 30 millimeters in y-axis. So let us see, we are moving at a rapid speed because G001 is used for rapid movement. So we are moving in a rapid way with x70 and y30. All right, since we are not changing z, so it means that z would remain the same, which is 10. So we are not writing it down here. So now if I look at if you can look at my hand, so if this is the workpiece, so now my tool or the drill tool is right at top of hole number 1. Do you understand this? G, please somebody to respond. Do you understand this, that while executing the second line, now my drill tool is right on the top of location number 1 where I want to drill the hole. Okay, so now in this line, which is N003, so we want to drill the first hole. So it means that now our drill bit is going to come into contact with our workpiece. So it means that it is going to now cut through our workpiece. So that means that we need to go with an interpolation. So this G01 is the linear interpolation. All right, and we have talked about it that whenever we talk about the linear interpolation, so the feed rate is going to be included, and this feed rate is given to us as 0.05 revolutions per second, and we have set this with the help of G95, which tells us that we would be talking about a feed rate of 0.5 millimeter per revolution, because G95 depicts the feed rate in revolution per minute. Now at the same location x70 and y30, the z is now given as -15. So it means that this is going to go through the 10 millimeter thickness, and it is going to go into this workpiece to drill a hole, and then it will be moving at a spindle speed of 1000 rpm, which is given to us, and M3 is the command for machine start. So now my drill is rotating at 1000 rpm, and it is going to go to Z minus 15 with a feed rate of 0.05 millimeters per revolution. G. Now, do you understand this? So it means that now we were at the top of our workpiece, and now the drill machine or the drill bit is going to go like this into our workpiece and drill a hole for us, and it is going to go to Z minus 15, where I'm pointing my or touching my finger at the moment, the right hand finger. Okay. जी, यहाँ तक have you understood this point? जी, can you please respond? Somebody to respond, please. जी, am I audible? Okay,
Yes,
that's great. So if you have understood this, so let us now move forward. So now what we have done until here, N003, that we have drilled the first hole. Now we have to retract the drill from the hole. So N0004, again, we would be using G01. If we do not write down G01 here, it doesn't matter because it is already taking G01. So I might not write G01 here. And then Z10. So it means that if we were in this position when we drilled the hole, so now the drill will be retracted back to the top of my workpiece. So this is the retraction of the drill, and again we will be retracting with the same feed rate in which we drilled the hole. Okay, so now again we have come on top of our workpiece. So now let's see in N005, again now we are using G00. So we are moving at a rapid speed to Y60. So from hole number 1, now we are going to go into Y60 and we are going to reach hole number 2. So this is actually the rapid move to the second hole location. So we moved our tool from first location to the second location on the top of the second hole. And then we are going to, now since we have used the G00 here, so while we are carrying out we are drilling the second hole, so since we have shifted from G01 to G00, so we have to go back to G001. And when we talk about G001, so since we have moved rapidly in the previous line, so again we have to give the feed rate. Again we have to give the feed rate, which is 0.05 millimeter per revolution, and we are going to move to location Z minus 15. So now we have drilled the second hole using this line. Then we have retracted the drill again. So we might not use G01 here, so we can just cut it off. So we will retract from the drill from the second hole. So this was actually this was drilling the first hole. This is now drilling the second hole and coming out of the hole. And then again we will repeat the same, and with the help of G00 we will move to 120 and 30. So this is 120 and 30. So we reach at on top of hole number 3. So we will drill. This will be rapid movement, N008, then N009. We are going to drill the third hole. Then we are going to retract from the third hole. in the same fashion as we did in first and second hole. And then in line number 11, we will rapidly move to the target point and the spindle will stop. And this would be the target point from where we started. And M05 is actually shows us the stop spindle stop. So it means that the spindle will stop rotating with the help of M05, and M30 would tell us that this is the end of program and the machine will come to a stop. So there will be no more movement in the machine. Okay, so but just by looking at this alphanumeric code, with the lines starting from N001 to N012. So in 12 lines of code, we have been able to drill 3 holes as per the requirement in this workpiece. G. So have you been able to understand all this? जी मुझे बताइए if there is any question until here. We are 13 people on board, so if you have understood this, so it means that you should be able to write down the alphanumeric code, keeping in view all these things. Is there any question?
Sir, ये जो alphanumeric code हैं, ये हमें याद रखने पड़ेंगे?
And you will have G and M code table with you all the times, even during the exams. And this G and M codes during the exam will be provided with the question paper. So you don't have to remember these alphanumeric codes.
Right.
Okay, any other question? All right. If there is no more questions, so let us move forward and now look at another example. This is the example. This is the same example which we have discussed in the previous problem. Again, 40 millimeter above the surface of the machine tool. Okay, 40 millimeter above the surface. And now you are given a 200 millimeter end mill with 4 teeth will be used. Okay, so now this is the end mill. So it means the end mill means that you need to carry out the cutting from the edge of the from the edge of your workpiece. So it means that this is your workpiece. So you have to cut the edge of the workpiece with the help of your cutter. As you can see, the movement of my fingers as a tool and my left hand as the workpiece. So this is the movement which will carry out the cutting of the sides. Okay. All right. So this is all given in this. Let me just read through. Is the cutter has a side tooth engagement length of 40 millimeter. Throughout the machining sequence, the bottom tip of the cutter will be positioned 25 millimeter below the top surface of the part, which corresponds to Z minus 25 millimeter. So ये जितनी हमने कहानी पढ़ी है, इसमें सिर्फ एक चीज important है, वो ये है that our Z dimension will always be minus 25 millimeter. So it means that whenever we come in contact with our tool comes in contact with the workpiece. So Z would always be minus 25. Since the part is 10 millimeter thick, so this Z position will allow the side cutting edge of the milling cutter to cut the full thickness of the part during profile milling. Okay, the cutter will be operated at a spindle speed. So we are given a spindle speed of 100 revolutions per minute. Feed rate as 50 millimeter per minute. So अब देखिए ये हमें 50 millimeter per minute के हिसाब से दे दिया गया, वहाँ पे हमें 0.05 millimeter per revolution के हिसाब से दिया गया था. So let's see कि इससे क्या फर्क पड़ेगा. The tool path will be followed as shown in the figure. I'll just show you the figure, and then cutter diameter has been manually entered into the offset register, which is 05. ठीक है? So ये register है जो जिसको कि हमने D05 करके लिखना होगा during in our program. So at the beginning of the job, the cutter will be positioned so that its center tip is at a target point located this. So this is the place from where our cutter's initial position would be. Now let us see that how this is to be done. So this is the diagram in which we have to cut the profile now. So you can see that we have mentioned N001, N002. So these are the lines. Then N003, and this is how it is going to move all around the workpiece and cut it down for us. So let us see how that alphanumeric code would look like. All right. So N001 is defining the origin of axis. So we have done that. Millimeter, absolute coordinates, origin or initial position, which is given to us like this. Now N02. So N02 is that our cutter would be moving rapidly to this location while starting the spindle and machine is on. So it is going to, so N01, 001 and N002 are here. So this will be the position of our cutter at the moment. Okay. Now what we are going to do now, we are carrying out and we are now engaging with the part. Okay. Engage the part and start the cutter. So G01, so we are carrying out a linear interpolation. Now this is the feed per millimeter per minute, feed per minute, और इसको हमने इसके साथ लिंक कर दिया F50 के साथ. ठीक है. Then we have given a cutter offset. Cutter offset according to the register D05, which is told to us. So now we have engaged our tool with our workpiece. So this is line number 3, in which the location of the tool can be seen here. Now it will start moving. So it is going to move to X160. So this is going to mill the lower part edge. Then it is going to move to Y60, which is going to mill the right edge. So this is C, N04, N05. Then G17 means that it is going to use the XY plane, and it is going to cut an arc in the counterclockwise direction, arc in the counterclockwise direction, and this would be its new or ending point, in which it is going to cut an arc of radius 0.03, which is given to us in the drawing. So this arc is cut while we operate line number 6. So line number 6 पे जब हम operate करेंगे, so हम 5 और 6 के दरमियान we are going to cut the arc. ये वाली arc जो मैंने आपको ये दिखाई है. So line number 5 and 6 की operation के दरमियान we are going to cut the arc. Then line number 7, again we are going to move in a linear interpolation fashion. अब हमने देखो एक दफा feed लगाई हुई है, तो feed वही चलती जा रही है जो हमने G94 and F50 के लिए लगाई थी. ठीक है. Then 35, so it will be line number N007, यहाँ तक आ जाएंगे. Then X0, Y0, so we are going to come to here, and this will be cut, this line, this will be operated, and the slant will be cut here. Then here you see that G40, so this is the cutter offset. Cutter offset is set to off. So it means कि जो हमने G42 की मदद से we had put in a cutter offset, so we have now finished this cutter offset with the help of G40, and then we will be rapidly moving to X-40, and this is the location where we will reach now, and then the machine will stop. So we have rapid exit from the part, we have cancelled our offset also, and then we will move to the target point, which was given to us as 0, y minus 50. And since you see that z we have not changed, so अभी तक z हमारा यहाँ क्या चल रहा था, अगर मैं just I want to write it down, so z हमारा last जो हमने डाला था, that was this minus 0 minus 0 to 5.0. So z हमारा यही चल रहा होगा, and then we are going to stop the machine. So this is how we are going to carry out the profiling, milling profiling of this part. जी, ये आपको क्लियर हो गया? जी, okay. So this is what we had to do today as far as some part programming is concerned. So let me introduce you to the CNC part programming. So can you see the CNC simulator in front of you now?
Yes, sir.
Okay, so I'll just briefly go into only those tabs which will be helpful to us. So let us see. If we see on the top, if you look at the arrow of the pointer of my computer, so you can see these tabs which are files, edit, simulate, screen, setting, help, and plugins. So let me just first go into screen. So if you look at screen, so this is a standard side screen. It shows you the status of the movement of the tool also. And here we have two options, milling and turning. So I have switched on milling, and I can see a workpiece, a rectangular workpiece in front of me, which is shown with the help of two solid white colors workpiece. If I turn the turning on, so just let's see this. If I turn the turning on, so now this will be a round shaped. This will be a round shaped part which is held in the jaws of a lathe machine. So since we will not be dealing with the lathe machine today. So this I will leave it to you that you can program some of the making some parts on lathe using the G&M codes. So I will not go into the detail of the lathe part. So let us go back to the screen in which we are using the milling. So this is the milling operation which we want to carry out. So this is the XY. See, this is the XY plane. You can see this XY plane. If you want to change, then you can just you can see the YZ plane. You can see the XZ plane also. So let us go back and you see the XY plane. All right. So this is the block in which you can see its 3 dimensions. So you can see it in a 3D view. And this is a block, means that it is seen as a solid. The block is seen as a solid here. And in the 3 dimension, this is a hollow portion which is shown to you. ठीक है, सो आप इसको ब्लॉक में कन्वर्ट कर सकते हैं, आप इसको दोबारा हॉलो में कन्वर्ट कर सकते हैं. सो यू कैन गो टू ब्लॉक, यू कैन गो टू 3D. सो ये सिर्फ आपको दिखाने के लिए है. सो ये दिस इज द स्क्रीन सेटिंग फॉर द for your part. Okay, so now we have now done this. Screen वाला हमने कर लिया. So now let us go to simulate and let's see what is the edit tool. So while we see edit tool, so let's see. And now look at this the second column in which the tool number is given. So this is tool number 1, tool number 2, tool number 8, tool number 4. All right. And this in the third column, the dia of the tool is given. All right. This is the dia of the tool. Okay. This is the length of the tool given to us. Its feed is also given to us. All right. And this is the name of the tool. Okay. So you have how many number of tools here? You have 100 number of tools here, but all the tools, or see, all the tools are not filled up. So we have actually 30 tools here जो कि हमें नजर आ रही हैं. ठीक है जी? So you can select any of the tool. 30 tools we have here. So you can select any of the tool depending upon the dia. ठीक है? So यहाँ से you can select the tool. So I'm cancelling it out. So let's go to the next. Then so this was the selection of tool. Then is the detail setting. So these are the detail settings. So you can set the length, width, and height of your workpiece. Let's see if I make it 200, width is 50, and its height is, let's see, 20. So I can see something like this. Okay. So I go back and edit its setting to 100. Since I have written a program for 100, 110. So that is why I am putting it back to this. So this is the edit. All right. 0 point register, leave it. If you want to load some extra tools, so you can load some tools from these. If you have a tool file attached with you and you have a tool file. So since we do not have a tool file with us, so then we will only restrict ourselves to two tabs here. One is the edit tool, in which we select the tool which is with us, and second is the editing, that we are going to give it a dimension. All right, so let's go back here. All right, so these are the tools which we are going to use. All right, Acha. Then these are something which will give you cut, paste, delete, some things like this. You can you can write renumber. So start the numbering from 10 and increase the value by 10. So this can be done automatically, or you can write down the number of the line by just by let's see, just by writing down it here by at like N001. N001. So this is line number 1. I have not written this. So let me just write some of the lines here. So you can write down the lines with all this. Okay. So now here you can see X, Y, and Z axis. So these are actually the coordinate systems, the coordinates of the tool which would be given to you during the movement. So at this point of time, we have set our tool at X0, Y0, and Z5. So this is actually the initial position of our tool, which is set into this simulator. All right, and where our X0, Y0, and Z0 belong to this point. X0, Y0, and Z0 belongs to this point, which is actually, look at this pointer. So it is the top corner of the top surface corner of my workpiece. So this is the default setting, unless you set it, you give it another point. Okay? So this is the default setting. All right. So I have just written down the code here, and this code is actually is going to give me and is going to make two slots, two longitudinal slots into this workpiece, and drill a hole in the center. All right. So let us see that how that can be done. So while I run the code, you just keep watching the movement of the tool in this block, in which you will see that the material is cut. And please have a look at this 3D block also, where you will be able to see the tool movement in the 3 dimensions. You won't see the tool movement here. You will just see the effect of the tool being created here Whenever it is going to come in contact with the workpiece, so the color of that portion will change. And in this 3D block, you will be able to see the movement of the tool. So I'm now going to execute this code, which is written here in the blue window. So before I execute, have you understood that what all we are doing here? I have told. Okay, कोई क्वेश्चन है यहाँ पे तो प्लीज मुझे बताइए, फिर हम इस कोड को भी थोड़ा लाइन बाय लाइन देखेंगे. ओके, अगर कोई क्वेश्चन नहीं है, so now how to run this code? So you can see an icon here. You can see an icon here. So I'm going to click this icon. So now I'm going to have these 3 icons in front of me. So if I press this 0, this icon with a hole, so my program will stop. So I go back. All right. If I start pressing this icon, so the code will be executed line by line. Okay. So let me just start this. So this is line number 1, which has been executed, 2, 3, 4, 5, things like this. Okay, so I'm going back now again. And this is the simulation, or this is the code, this is the icon. If I press this icon, so the whole code will run in one go. So let me just run it for you. So this is the, I'll explain it later. Just see that how the tool is moving and how we are carrying out now the profiling. All right then, and this is the removal of the part. Actually this part must have fallen down, but just to give a more. So now this is the final final shape. This would be the final shape of our workpiece which we have carried out. Okay, so let us go back and reset it again. Now what I'll try to run it intermittently so that we can see. So let us see what does the first line say. We are using all the default values. We have not put in G21 or anything else because it is working in millimeter as a default. So you can see it here now. So let us see the intermittent one by one, and I can actually, you can reduce the speed of the movement of the tool by sliding this bar. If you can look at this, so you can, by looking at this, you can see. So I have reduced it to 50%. The speed of the movement of the tool has been reduced to 50%, just to see that how can we explain it. So let me just now execute. So this is something which has shown us. This has shown us that our machine has started. So it means that our spindle has started to rotate. All right, because we have given S1000 here. So machine has started, and S1000 means that now it is rotating at a speed of 1000 RPM. Okay, what would be the next step? Now we have selected the tool T01. Okay, very good. Now we are going to, in the next step, we are going to rapidly move to X0, Y0 and Z10. So see, our tool has appeared here. If you can see in the third dimension, in the 3D graph, so you can see that now our tool has moved to this location, which is X0, Y0 and Z10. So we can confirm it from here also. X0, Y0 and Z10. And see, we had switched on the mist also, switched on the fluid, this coolant also, which can be now seen here with this tap running. All right. So we are using tool number 1 here. If you look at this, so we are using tool number 1. Our feed is 100 and our spindle speed is 1000 RPM. And this is the location. So let us move forward. And now what we are going to do is that we are now going to move to X15 and Y15. So this we have moved to X15 and Y15, but still our tool has not come in contact with the workpiece. But you can see now across here that it means from the top, if you see that our cutter or our tool is here at this place. So next step is G01. अब इसकी feed हमने 100 लगाई हुई है और ये अपने default में चल रहा है. So feed is 100. So now it is going to move to Z minus 10. So now it is going to come in contact with our workpiece. So see, now it has moved down. See, अब देखिए, अगर इसको आप देखेंगे तो आपको नजर आएगा कि our tool has gone in. See, और ये आपको जो कलर्स हैं ये आपको ये बता रहे हैं कि जी now they have gone to a depth. And if you can see in the block, so you can see that this is the hole being cut. अब next step में क्या है कि it has to move to X15 and Y85. So see, ये देखिए. So now it is cutting the groove. Then with a rapid speed, it is going to go to X85 and Y15. See, देखिए, बाहर निकल आया. देखिए, Z10 पे दोबारा आ गया, G00 से. Now it has come up. So you can see that your tool has come out of the workpiece. Next, X85 and Y15 पे चला जाएगा. ये देखिए, X85 and Y15. Now it is going to go into the part again. ठीक है? Now it is going to cut the second groove. ठीक है? फिर दोबारा second groove से बाहर आ जाएगा. अब ये देखिए M06 and T, तो आप ये tool change कर रहे हैं from tool 1 to tool 2. So now see what will be the tool 2. So tool 2 अभी आपको जब आप देखेंगे, so you will see कि ये देखें जो आपने tool 2 अब select किया है, which has moved to X50 and Y50. So इस tool का dia is larger. तो ये tool 2 हमने अपने उसमें से जो repository है उसमें से हमने इसको उठाया. So this is the tool 2 which is now going into the into our workpiece to drill a hole, coming out, and now we will be, now see, we have now selected tool number 9. ये देखें, tool 9 हमने select कर लिया and it has gone to X0, Y0 again, और Z already इसका 10 हमने यहाँ पे देखा हुआ था. Now it is going to go into Z minus 10. So ये देखें, अब this is going to go come in contact. See, ये देखें in contact आ गया और इसने थोड़ा सा मटेरियल रिमूव कर दिया. नेक्स्ट स्टेप में नाउ इट इज गोइंग टू मूव और ये जो आपकी लोअर पार्ट है इसको कट करेगा. यहां तक. अब ये देखिए जो रेड आपको नजर आ रहा है, अगला वाला क्या है, X100, Y10 एंड R10. सो ये अब कर्व लगाएगा. ये देखिए, इट्स मेकिंग अ कर्व नाउ. फिर स्ट्रेट मूव करेगा. सो इस तरह से मैं इसको थोड़ा तेज तेज चला देता हूं. अभी ये यहां से ये फिर कर्व लगा दी, फिर एक स्ट्रेट कट लगा दिया. थोड़ा सा मैं इसकी स्पीड को बढ़ाता हूं. another curve, then straight movement, another curve. फिर आप देखें दोबारा अब ये टूल T01 सिलेक्ट करने लगा है. ये देखें T01 इसने फिर सिलेक्ट कर लिया. ठीक है, और फिर अब ये साइड वाली जो ये देखें इनको रिमूव कर रहा है वन बाय वन. सही है. M05 पे हम पहुंच गए, विच इज मशीन स्टॉप. So जब मैं मशीन को स्टॉप करूंगा तो आप देखें ये स्टॉप हो गया, M09 आपका कटिंग फ्लूइड ऑफ हो गया, and your program will come to a halt. ठीक है जी. So this is how you can program your G&M codes with the help of the CNC simulator. So I have given you a very cursory touch of CNC simulator, in which you would be using only two tabs, in which you are using milling and you are using your simulate to edit tool and detail setting. So these are the three tabs actually you will be using. You have this software with you. You can use it as much as you can to build up your skills for this. But as far as our course content is concerned, so you only would be using it for these three tabs, or two tabs in which three definitely, and then you can finally. अच्छा, यहाँ से आप ये करेंगे कि आप इसको कॉपी करके जो भी आपका ये प्रोग्राम है इसको आप कॉपी करके देन यू कैन मेक अ टेक्स्ट डॉक्यूमेंट, और इस टेक्स्ट डॉक्यूमेंट में आप इसको सेव कर दें. ठीक है. सो इस तरह से आप सेव करके आप ये कर सकते हैं. ये मैं आपको क्यों बता रहा हूँ? ये मैं आपको इसलिए बता रहा हूँ कि मैं जो आपको अगली असाइनमेंट दूंगा उसमें आपने इसी को यूज करना होगा, CNC टूल को यूज करना होगा, और यू विल बी राइटिंग डाउन योर नेम्स. आप अपना नाम क्या लिखेंगे, मैं वो आपको एक पूरा एनेक्स दूंगा विद दी क्या नाम है, विद दी असाइनमेंट दैट विच स्टूडेंट हैज टू राइट डाउन व्हाट नेम. ठीक है. So वो मैं आपको सारा दूंगा, and you have to use this CNC simulator, and then you will send me this file जो कि मैंने अभी आपको बना के दिखाई, जो टेक्स्ट फाइल है. So I'm going to copy your code, put in my simulator, and we'll see that how will it work. Okay जी, यहाँ तक मुझे बताइए जी, is there any question? I have shared this CNC simulator with you. जी, एनी क्वेश्चन? किसी का कोई क्वेश्चन नहीं?
नो सर. सर टूर डाउनलोड के लिए सर ये सारे कोर्सेस अभी ट्राई करते हैं.
जी नहीं, सॉरी मैं आपकी बात नहीं समझा, दोबारा बोलिएगा.
सर कह रहा हूँ सर फिलहाल तो कोई सवाल नहीं, अभी वो टूर LMS से डाउनलोड कर लिया तो ये सारे इसको फिर ट्राई करेंगे, फिर सारे ये
हाँ, बिल्कुल. अगर वो आप अपने ऑन टाइम में प्लीज डू प्रैक्टिस, अपनी स्किल्स को बेहतर करें. बिल्कुल, यू आर एट लिबर्टी. आई हैव गिवन यू दिस CNC सिमुलेटर. आपको मैंने कल ये मेल कर दिया था, LMS के ऊपर अपलोड कर दिया था. You can download it and then you can use it as much as you can. While you will be writing down your name, so you will make up your skills. उसमें आपको और भी इसके अलावा आप फिर ट्राई करना चाहें to जो लेथ है उसको ट्राई कर लें. सो आहिस्ता आहिस्ता you can build up your skill on this. But as far as our course is concerned और your जो assignment is concerned, उस assignment में आपके यही 3 tabs जो use होंगे, इसी से you will be able to make your assignment. ठीक है जी. So if there is no more questions, so I'll now switch the recording off.